All right, so let's go ahead and try number 10. All right, so find the distance from the points. Let's really quick write out our step. What's the first thing we need to do? Alex?
Find the perpendicular line.
Good. Find the equation of a line perpendicular to the given line. Okay, and the reason we have to do that, remember, because if our equation is like this, and point Q is over here, the distance from point Q to that line is a perpendicular line. So we need to find the equation of this line, and then we have to find that coordinate where they intersect. So first step, find the equation of the line. And remember, if it's perpendicular, remember what we know about the slope there. Okay, so go ahead and find that equation. Okay, so the equation of a line, first we need to know the new slope, which would make it helpful if we actually put this in slope-intercept form. So we get negative y equals negative 5x plus 6 divided by negative 1. So we get y equals 5x minus 6. So our perpendicular slope is going to be the reciprocal of that. And then we have to flip the sign. So our new slope is going to be negative 1/5. Okay, how many got that? All right. Any questions on how we got that? Okay, let's use that and a point. If we call this x1, y1, okay, we'll use y minus y1 equals m times x minus x1. Okay, y minus negative 4 equals negative 1/5 x minus negative 10. Okay, two negatives make a positive, so we get y plus 4 equals negative 1/5 times x plus 10. So y plus 4 equals negative 1/5 x minus 2. So y equals negative 1/5 x minus 6. How many made it that far? Okay. Any questions up to there? What do we do from there? So we found that was the first step. It's quite a first step. Now I have these two equations. What can we do with that? So we now have this equation. We have this equation. We need to find,
You subtract it from the line is perpendicular to.
good. So you have to find the point of intersection of those two equations. So by using elimination, we can find that point of intersection. Okay? Or use substitution. I'm going to use, so solve a system to find the point of intersection. Alright, so if we take y sub 1 and y sub 2, we can say, okay, our first equation and our second equation, and if we add those, Maddie? Yep. Okay, if we add these, notice if I add them, I don't have opposites yet, so I'm going to flip all the signs on my bottom one, so I can now have opposites. I can add the two. This disappears. This becomes 5 1/5 x. And this becomes 0. Okay, so we get 0 equals 5 1/5 x. What's x? So 5 1/5 times what gives me 0? 0. So x has to be 0. So if x is 0, what's y? Y is what? -6. Yeah, if I plug it back into either of my equations here, if I plug it in right here, y equals 5 times 0 minus 6. So y equals -6. So they intersect. The point of intersection is at 0, -6. That would be like that point right there. This probably isn't a good picture for this because that's not a negative slope, but whatever. Okay, 0, -6. Now we need to use the last piece here is finding the distance using the distance formula. So number 3, use the distance formula. Okay, so we have one coordinate, we have another coordinate, and we use the distance formula with those two coordinates. So d equals the square root of, we call that x1, y1, we call this x2, y2. So x2 minus x1 squared plus y2 minus y1 squared. So that's 100. And this is a plus. So that's 4. Root 104, which is approximately 2 root 26, which is approximately 10.2. That is our actual distance. Sam? Using this coordinate and that coordinate. So like in my picture, it would be this point and that point. Okay? Yeah? Sure. Yeah, you could leave it as 2 root 26. Unless they tell you to round. Okay. Isaac? You could graph it and use the Pythagorean theorem. Yep, you could do that as well. Alright? So if it makes more sense to graph the point and the equation, use the Pythagorean theorem, it's all good. Yep. It's a nice picture format on it then. Okay. You guys, 13 I'm not going to worry about, but number, because we're not doing anything like 13. Okay? But number 11, a line through 3, 5 and k equals 12 is perpendicular to line 0, 7 and 2, 10. Find the value of k that makes the above statement true. Okay, so what we know is we know 3, 5 and k 12. All right, and we have 0, 7 and 2, 10. All right, so if I did the slope formula for each of these, because we want them to be perpendicular, so we need their slopes to be inverse reciprocals. If I did the slope formula for each of these, that would be 12 minus 5 and k minus 3. Right, so on the top here I end up with 7. On the bottom I still have k minus 3. Jeremiah, are you helping him? Oh, he's helping you? What's he helping you with? Oh, okay. All right, 3, 2. Very good. We need the lines to be perpendicular, so I know this slope is 3, 2. What's a perpendicular slope need to be? Needs to be 2 over 3 and negative 2 over 3. Okay? Since the lines have to be perpendicular, we have to do negative 2/3. So I went all the way with the one I know here in terms of the slope. If that's negative 2/3, that means this answer up here eventually has to equal negative 2/3. All right. Well, this is a 7, and there's no way to make that a 2. Brennan? You could double this to get 14. But that now means I need to double this one. That gives me 2k minus 3. Did that help? Can I make 2 into 14? Yeah, what would that be? So if that's 14, what's the bottom? Yeah, negative 21, right? You guys see that? So if we're taking a look at this right here, this equation right here, or excuse me, that expression, has to equal that expression. So what equation can we get out of that? Those parts are the same. Which parts are different? The bottom. Okay, so there's our equation that we want to solve. Negative 2k, or excuse me, 2k, or 2 times k minus 3 is equal to negative 21. So 2k minus 6 equals negative 21. 2k equals 27. That's, oops, I'm sorry. I messed that up. That would be 15, I think. Negative 15, thank you. And then k is equal to negative 7.5. There's other ways to do it. You could have done it a different way.